Hey guys, welcome back. This will be the first video of our series. We're going to be creating our first shell script. So we're going to be going over things like what is a shell script, creating a script, choosing a name for it, setting permissions, and running your script. So let's jump at it. So let's begin with a simple but famous hello world example. So all we're going to be doing here is like echoing hello world to our screen here. So as you can see, all we're doing here is like echoing hello world. Now suppose that you have the need to run this code on the regular basis. Bash will let us save this code in a file, so then we can run it as a program. And such a program is called a shell script. Now to create my script file, I'm going to be using a text editor. I'm going to be using Vim, but of course you can use any editor you want. So let's first create our hello world file here. I'm going to be using Vim. I'm just going to call it hello W. This is going to be open in Vim with a file name called hello world. Hello W actually. So now the simplest possible way to write our hello world will be like doing the same we just did on the terminal. So do echo, and then we do the same. Hello world, and then we save the file. Oops. And we exit. So now if we try to run this hello world file, it says command not found. And the reason for this is because our hello world program is not on the path where bash looks for executables. So let's do something different then. So let's tell it that it should call it from the current directory. So and now we have a different error. So now we're getting permissions denied. So let's fix that. I'm not gonna be going like deep here into permissions and file permissions because in my opinion that's more like a Unix course, but I'm gonna be giving you the basis here so you can change your permissions to the file. So if we list the files we have on this folder, we do ls-la, we see our hello world file here, and we see that currently our user have like read permissions, have write permissions, but then we don't have executable permissions. So that's what we need to fix here if we want to execute our file. So we need to change mode here for the user, and we need to add executable permissions to the hello world file. So now that we did that, we should be able just to locally call it. And as you can see, now we're able to execute the file and it's printing our output. And if we go back to ls-la, you can see that our user is able now to execute the command. So basically what happens here is like batch is trying to execute the file. It sees that it's a text file and starts reading each line in the file, interpreting each line as a bash command, and finally trying to execute that. So let's go back to our slides and just review what we just saw here. So as we saw, guys, a script is nothing else and nothing more than just a text file containing code. Usually scripts are run by an interpreter, and since this course is all about bash scripting, our interpreter will be bash. And what it does is that it will read each line in the file, and for every line that contains a command, it will be executed in order top to bottom. Actually, that's not entirely true, but we'll get to that soon. Now, to create and edit your script, you will be needing a text editor. And believe me, choosing the right one will make your life much easier. So here are some suggestions. So Beam, by Text Wrangler, Emacs, Notepad++, there's plenty out there, so you name it. So as you saw, we use the chmod command to change permissions to our file. Now all we did was like change the user's permission and we added executable permissions to it. So we were able to execute the file. By the way, you can make a file executable by everyone on the system, just replacing the U with an A. That means all. And the same way you add permissions with a plus sign, you can just remove it as well with a minus sign. For more about permissions, just follow the link below. Now let's get back to the terminal and create some more useful scripts. Of course, the Hello World script is the simplest possible example of a script. And so it's not really representative of what the real world script looks like. So to give you a more realistic example, let's start on a script that will expand on later on the other module we're going to be working on. So suppose I will like to be able to create like a to-do list with my grocery a list and just add them to a file. So for that, let's just create a new script. So if you notice here, I'm using like Visual Studio Code. So I'm going to be using that one here. So let's create a new script that is going to be called td as to-do list, td.sh, and let's just copy our script here. So all of this code, I'm going to put it on a GitHub repo, so you're going to be able just to download it. So let's first start looking at the first line here. It starts with like two characters called either shebang or hashbang. You can call it either way. So are these two symbols here. So this is a special line. So this line declares that this script file is meant to be run by bash. But you could also use as well any other like interpreter you like. Like you can use like Python or you can use like C shell, anything you want here. So now when a user runs another shell, let's say they runs like a C shell, he can still use our script because when he calls a script from his shell, the first line will be read and bash will start to run the script. So by adding this first line, we make sure that script doesn't get interpreted by another shell. So make sure to always put this line at the first of your script. Now, below the shebang are two comment lines. Adding comment to your script is a very good habit to make your script understandable and maintainable. And as you can see, everything after the hash sign is a comment, and the interpreter will ignore it. So let's explain the actual code that is this single line here. And this is really a quite simple script. The $1 gets the value from a variable called 1. And that is a special variable which denotes the value of the first argument being passed on the script. So echo here will print that value to its output. And then we redirect it to a file called to-do. So then let's save it and then let's try it. So we're saving it. And then if you remember from our previous video, we need to make this file executable. So we need to add permissions to it so it's able to execute. So if we do ls-la, we see that this to-do file here we created doesn't have execute permission. So let's change mod and then we do the same. User plus execute and td. Perfect, so we should be good now. So let's give it a try. So if we call it td and we just pass something, let's say by x. So let's cat that. the name of the file we create is to do. So as you can see here, we only have by. Why is that? The problem is that we're specifying as part of the script, only one argument is coming in through the command line. And the way Bash see this is that we're passing two arguments, so it doesn't know how to handle this argument right now. So if we want to fix that, let's do the following. We want to buy X, but we want to buy X in quotes. So now if we cat that file, we have buy X. Perfect. So if we don't want to be quoting or text every time we're going to be passing something, there's something else we can do. So we can go back to our script here, and instead of like using one, we're going to use a wildcard. We're going to be doing this. We're going to come back to this in a second. So let's save this and let's do it again. So if we go back now, we show that again. We see that we have like buy more X and we didn't have any troubles with that. And the reason these items are getting a pen and not overriding is because we're using two greater than signs. If, for example, we use only one greater than, that's not gonna pen. That's gonna override every single time to this list. So let's try that really quick here. We do that and then we go back and we cat that. You can see that only one item is not on that list. And if I do it again, more X, and I go back and cat, only one item. So what we want is we want to have like two greater than, so every time it will append at the end of the list. So now let's just suppose we want to add the date and time when that node was taken. We can use like the date command, which outputs exactly that information. And to put this in like a node file, I can use something like called command substitution. So let's do that. We go back here and we do date column. So the column here is nothing special. I just like to add the column after the date. And this is only to show where the nodes start. So now let's just save this and try it. Save the file and let's buy milk. If we cat that, now we have that we need to buy X, and then we're appending the date and time to our to-do list. Now, the only thing I don't like about this script is that I have to call it with a full path name every time. So let's just say I'm in another directory. This is not gonna work. So if we want to avoid typing those characters every single time, and when I say those characters, I mean the /, which indicates you're on the current directory. So one thing we can do is we can add it to the path, so Bash will find it. So I recommend like creating a directory where you keep all of your scripts. And usually then like the traditional name for this will be bin. So just for the fun of it, we're gonna create a directory called bin instead of my current one here. So let's see. And then let's move our script to that folder. We already have it there. So now we need to add that to our path. So now let's add it. So I do path. will be equal path, then where we want to find that script, which in my case will be uh, so let's do this slash bin, and we should be able just to call it like this, and then we pass need also butter. Then if we do cat to do, you see that we also need butter, and now we don't need to specify where the file is. We just do td and it will be able to find it now that we add it to our path. And just to make sure this is working, let's get out of like this. Actually, we already tried it because we don't have it here and it worked. I thought we already had it here, but just remember that we move it inside of the bin folder. So with td add x, there you go, add x. So it's finding it directly from the path. So it doesn't matter where you're standing on or any directory, you will be able just to call it directly. And something that you need to have really clear now, since we're going to be able to call this from no matter where, you need to have like a full path of where you want your node to be saved. Otherwise, if you don't have like a full path, it's going to be just saved to whatever is the current position, your current directory from where you're calling that script. So you just need to have that clear. And finally, let's just add one more line of code to this script, because if something happened, we would like to have like confirmation that we actually got that item added to our list. So let's do that. So we'll echo, and then, so let's try that. And let's call our td stage and bring soda. We cat or to-do list here. Let's try that. So I see what happened here is like actually we moved this file inside of bin, and since I had this open, when I hit saved, this item got created again. But I bet exactly this one doesn't have the new line we just added, so we need to actually do it on this one. So if we call it td td bring sugar, we now have like our new line indicating that a new item is being added to the list. Perfect. Okay, so let's take a look at the slides and try to summarize all of this. So we saw that you cannot call a script like a regular command when it's not on your path, and one way to work around this is to add the location of the script to your command line. Now, if the script is on your path, you can just simply call it like you will call any regular command. So my tip for you guys is to make a folder where you keep all of your scripts, just like I show you on the video. And the conventional name for this folder will be bin, and any script you put on there will be easily callable from anywhere on your system, as long as you make sure to add that directory to your path. Now let's take a look at the shebang. So I already showed you that it's a good practice to start all of your script with something called a shebang or hashbang. It should be at the very start of the file, and the line should start with a hash sign followed by an exclamation mark, which, by the way, another name for that exclamation mark is a bang, which explains the name hashbang. After these two characters, and you declare which interpreter should run your code, And you could also use this line to specify options for your interpreter. Later in this course, we'll see why you might want that. So the last thing I want to talk on this module is giving your script a name. A mistake that a lot of people makes when they start writing bash scripts is that they name their scripts like test, but that name is already taken by the command built in into bash, which means that we have a naming conflict. Basically, that means that we will only be able to run our script by giving bash the full path name because the name is already taken. So if you call your script something like test or if, you can only run giving bash the full path to it. The same problem occurs when you pick a name that's already taken by another executable on your path, like for example ls. In that case, when you type like ls, bash will first find the system-wide ls on the path, and so it will not run your scripts. So you might solve this by putting your scripts folder at the start of the path variable, but really I wouldn't recommend that. Instead, it's better just to pick a unique name for your scripts. So how do you check if the name is already taken? Well, you can use a type command. So let's go on and see how that works. So now that I'm on terminal, let's see what type tells me when I ask about the name called test. So let's see, it's type test. And as you can see, it's already telling me that test is a shell built-in command. So I shouldn't call my script test because as type is telling you, you already have one on your system called test. And what about, for example, type CP? So this tells me that batch already knows a command called CP. It's not built in, but it's actually a file located at bin/cp. But when I try a new name, let's say foo, so it's telling me that foo is not found. So probably if you want a name for a script, foo will be the way to go, or whatever you choose and that you check first. But this does not guarantee that when you run your script or you copy your script to any other system, they won't have like a script already called foo. So keep that in mind. And this brings us to the end of this module. We have seen what a shell script is, namely a text file containing commands to be executed by the shell, and how to create one. I've shown you how to properly choose the name for your scripts, and also that after creating a file, you shouldn't forget to set executable permissions with the change mod command. Furthermore, your script should start with a shebang line, also that any line starting with a hash will be ignored by the interpreter and treated as a comment. If you want to run the script, make sure you add it to the path or call it with the full path name. So as usual guys, if you enjoy it, please leave a like and subscribe and keep learning.